Boa tarde a todos e retornamos a Exibidor Tech Week na sua segunda parte do seu segundo dia. Para quem não me conhece, meu nome é Marcelo Lima, sou CEO da Tonks, empresa proprietária da revista Exibidor e do portal Exibidor. E em nome da Exibidor, não posso deixar os meus mais sinceros agradecimentos aos nossos patrocinadores, Dolby, Harkness, Screens e Christie. Obrigado a todos vocês por todo o apoio dado às soluções da Tonks, da revista Exibidor e, logicamente, da ExpoCine. Cada uma dessas empresas que eu citei estão presentes desde ontem até amanhã, apresentando soluções e caminhos para uma indústria sustentável e responsável para o que a gente espera dos próximos anos no mercado de exibição cinematográfica. E para esta segunda parte desse segundo dia da Exibidor Tech Week, temos conosco dois grandes executivos diretamente da Inglaterra, que são o Richard Mitchell e o Tony Dilley. Hello, guys.
Hello.
Yeah, good evening. Well, good afternoon. Good evening.
Good afternoon, yes.
Good afternoon here and good night there. Good evening. Richard e Tony apresentarão o tema Enriquecendo a Experiência do Cinema em um Mundo Pós-Pandemia. Antes dessa apresentação, peço para que todos também se inscrevam no canal da Exibidor, cliquem no sininho, porque a gente vai ter mais vídeos, além que, lógico, a gente vai ter os vídeos de amanhã da Exibidor Tech Week, e é importante a presença de vocês em todas essas apresentações, e vocês serão alertados a cada lançamento do vídeo. Além disso, aqui nos comentários, vocês vão conseguir também ter acesso a todas as demais apresentações da Exibidor Tech Week, das gravadas, inclusive agora há pouco da Christie, vocês também já vão poder ter acesso, e logicamente vocês têm acesso à tradução simultânea desta apresentação, né? Uma vez que o Tony e o Richard são da Inglaterra, eles vão fazer a apresentação em inglês, mas a tradução simultânea está disponível logo aí embaixo. Portanto, com vocês, enriquecendo a experiência do cinema em um mundo pós-pandemia. It's with you, Richard. Tony, good luck.
Thank you, Marcello. Thank you.
Thanks, Marcello.
Good afternoon to everybody. It's fantastic to be with you today. I think I speak on behalf of Tony and everybody at Harkness to say that we miss being with our colleagues, our friends and our partners in the industry. This past year has been incredibly challenging for everybody. It's great to be with you all today. The news around the world is becoming more promising by the day, so hopefully before too long we'll be able to be back together and meet in person and bring our amazing industry back to the fore where it belongs. Today we wanted to talk to you about the cinema experience in a post-COVID world, which hopefully we'll enter into in a few months' time, if not sooner, and how you should be planning for that, not just from the extent of procuring new technology, but making the best of what you already have, because we, as I'm sure every equipment manufacturer around the world is aware, budgets are going to be very limited. It's going to take time to recover, but there are things that can be done that we hope we can show to you today that are cost effective to enable you to give the best cinema experience to your moviegoers when they come back. So a rather long agenda for today, but some of these things hopefully we'll run through quickly. What we really wanted to do was to focus in the short term about this guidance for reopening, so hopefully next few months, about getting back to operation. So what to look out for in terms of the screens themselves. Then to look at that sort of midterm for those of you that have still got Series 1 and Series 2 lamp-based projectors installed, to really try and make sure that you can keep them operational and at the best that they can be for the period of time that you need to run them until potentially you need to swap them out. We're also going to look at the operational cost element of it, because we think that we can show you return on investment aligned to also making some improvements. One of the key topics that keeps coming up for us at the moment, not necessarily in Latin America, but around the world, is exhibitors looking to swap out some of their 3D screens where they've taken some 3D systems out So it's we want to just highlight to you the implication of just leaving a silver screen in if you're no longer using that screen for 3D. We'll also talk a little bit about laser deployments and some of the key issues that still exist around lasers, so things like speckle. And then what we really wanted to do is just to finish to give you a snapshot as to some of the work that we've been doing over the past 12 months to hopefully help the industry get back onto its feet. So without further ado, I'm going to pass over to my fantastic colleague, Tony. Tony's going to bring you some guidance for reopening over the next few months. Tony, over to you.
Thanks, Richard. Yeah, what to look out with your if you're reopening. I know in a lot of Brazil there are cinemas still open, but you haven't been shut for a long time. But any screens that are reopening where something like, sorry, I was muted. I do apologise. Right, checklist where you're opening up. I know in Brazil there's been a lot of screens that haven't really shut, and you've still got a lot of screens open, and it's territorial. Some places are shut, some aren't. So this will apply to some people and not others. The air conditioning, if it's been left on, you shouldn't have any problems. If it's been turned off and you're in an area of high humidity, you can sometimes get mold on the screen, particularly if the filters, the air conditioning filters, haven't been cleaned. If that's the situation, it's very doubtful you'll be able to do anything with the screen. You would have to replace it. Screens are put in under tension on their frames. They're either wrap rounds or lacing, and they are tensioned when they're installed onto the frame. If it's got very cold in the cinema, it's a possibility that the screen will be sagging where it has got cold. So you may have to retension the screen. Particularly with matte whites, the seams might be visible. That's because of the way the screens are made. So to get rid of the visible seam, you will have to retension the screen. Dust, obviously that's a big problem in most auditoriums. If you start moving in there and start moving about and cleaning it, you are liable to put a lot of dust in the air. It does help sometimes if a frame is earthed, but it should be anyway because it's screwed to the floor. But any way you can stop static building up on the screen and stop the dust being attracted will help. But try not to get too much dust into the atmosphere. The screens can be dusted, but it's not easy to do. And obviously, if the screens are wet because it's humid, then it's even harder to try and clean the dust off of the screen. Next one, please, Richard. Some people have been running the air conditioning at very high temperatures with some chemicals to disinfect the auditorium. If you can't heat our screens over something like about 35 degrees centigrade. After that, you're looking at problems. So don't try doing that to disinfect an auditorium. You can't use cleaning fluids on the screen. You can only dust a coated screen. And we can put something up on our website, or there are things on our website that will show you how to clean a screen. And again, as I say, you don't want high humidity when you try and clean the screen. If you are going to clean out your air conditioning, it shouldn't damage the screen. Obviously, it depends where the in and out is of the air conditioning. If it's behind the screen, then you need to be very, very careful, and you need to make sure that the AC is very clean before you turn it back on. If you don't, you will cause yourself problems. Richard? If you've got screens that you've been waiting to install, the majority of them will be in tubes. Now, they should still be okay. If they're a tube pack screen, although we say they should only be in there 12 weeks, if they've been stored correctly, then they should be okay when you come to install them. The trick is get them in an auditorium and get them to heat up to ambient temperature before you start to unpack them. And once you start to unpack them, then go through your normal installation procedure. Make sure the frame's clean. You might have to wipe it down, obviously. And the cleaner an auditorium is before you install the screen, the less dust will gather on the screen over time. Richard?
Thanks, Tony. So what we really wanted to do was to look at that very short-term opening, and hopefully some of that advice will be helpful to you as you come to reopening cinemas. The next challenge will be the transition to laser projection. Now, we're aware that that progress had started significantly, but is likely to have been derailed by the past year. And we've had a number of exhibitors talk to us about how they can make the Series 1 and Series 2 projectors last for potentially another 3 to 5 years whilst they build up the capital sums in order to replace them. Either that or potentially to replace the light engine within the projector. So the first thing that we would suggest, and I think every integrator or service company that you deal with will tell you, it's absolutely essential that you continuously replace those filters in the projectors, always using the manufacturer's specific filters. It's really essential that you do that. Make sure you continue, regularly cleaning the lamp house, and in particular the mirrors. The lens, of course, to remove any dirt or dust, and the same with the porthole on both the projection side, but also on the auditorium side. Doing that can have a quite significant effect, not just on the quality of the image and the brightness level, but in the case of 3D, in terms of polarization and ghosting. So if you're not sure how to do that, I would strongly recommend that you talk to a service company or your integrator to do so, or potentially even your projector manufacturer. Now, obviously, a lot of these projectors are somewhere between 15 and, let's just say, 7 years old. And of course, as we all know, over time, just the same as horsepower fall out of cars, the maximum lumen output of a projector starts to fall away as parts become older. Now, there are some manufacturers of projectors who offer prism cleaning. So this is a process where you send off either part or whole of the light engine, and they will clean the entirety of it out and help to restore light. They can do the same with lenses and lamp houses. They can be replaced. The prism itself can be replaced. I've actually seen the neck facility in the United Kingdom and seen the incredible work that they do there in terms of cleaning prisms. The uplift in output of brightness can be quite incredibly improved, probably as much as 80 to 90% if a projector has been used for a long period of time. It can be costly, for sure. It can be sort of between $25,000 and $30,000, but it may well be cost effective in terms of replacing the projector itself. And it's probably about equivalent to replacing the retrofit light engine itself, maybe even a little cheaper. But also, some projectors may or may not be compatible with a retrofit laser light engine. As always, recommend talking to the projector manufacturer to find out those available options to you. But they are things to definitely explore. Some of those parts are not as expensive as others. What about the screen? Well, H screens can have a reduced reflectivity or gain. We've seen some of our own screens that have been in the field for 15 years where the gain has not changed at all. We've seen screens in different auditoriums where it's more humid and dirty, and they've lasted 2 years. So yes, it's about environmental conditions. Typically after 8 to 10 years, you might see a drop off of 20 to 30%. But of course, that deterioration in the screen can provide a poorer presentation. So it could be that your brightness levels fall away. It could be that the polarization of a 3D screen has fallen and ghosting becomes more visible. And of course, with all of these things, poorer quality presentation means that you're going to, one, have disappointed moviegoers, but two, you're going to be running higher operating costs through higher wattage lamps, and possibly even having to use a projector at a higher power setting in order to up the brightness where that's still possible. And of course, if you're running higher wattage lamps, then you're running more lamps annually than you would do because of the operating hours of a lamp. So we were fortunate to be provided with some information from CTC, the Cinema Technology Community, from a white paper they produced just around October 2020. And here there are two examples on screen. And you can see that the starting brightness of these two different examples. So let's look at the left-hand side one. Starting brightness of 9.5 foot lamberts. So you can see the uplifts of just doing the cleaning brought half a foot lambert back to the screen. And then you can see where the big uplifts are. So in the lamp house itself, 5.3 foot lamberts, and in the prism replacement, 3 foot lamberts. So we've almost doubled the light in doing that. Now the cost for doing that, $26,795. But even if you'd have not done the prism replacement, which is a majority of the cost, you'd have still been looking at around about 15.5 foot lamberts for around about $7,200. So that gets you back inside of that DCI specification for 2D brightness of 14 foot lamberts plus or minus 3. And then on the right-hand side, a different set of actions were taken with this projector. So a starting brightness of 11 foot lamberts. Again, those cleaning elements went in, which added 0.7 foot lamberts back onto the screen. Here, a lamp house was replaced and a significant uplift. But what they also did here, where the other big jump was to replace the screen. So here they moved from a matte white screen to a Perlux high white 1.4 gain screen, which bought them just under 5 foot lamberts additionally. So again, for $14,775, they've more than doubled the light. And if you took the prism cleaning itself out, you'd be around about $11,000, but you would still have gained double the light. So showing you two different models, and sometimes it's a mix and match element that will enable you to get better brightness on screen and a better presentation quality. So what I wanted to do is to show you this table as well. It's quite a simple way of looking at it, but what it shows you is the ability to uplift that brightness. So if you have a projector where, let's just say you have a starting brightness of 10 foot lamberts, just by hopping one gain jump up across, for example, our own screen range, you can see the significant uplifts. So if you were starting at 10 foot lamberts on a matte white 1 gain screen and you move to a Perlux high white 140, you would have an increase of 4 foot lamberts, taking you to 14 foot lamberts. If you go from a 1.4 gain screen to a 1.8, you see a 2.8 foot lambert increase. And even on the bottom line there, that's showing a spectral 2.4 gain screen, the 3D screens that have been rolled out around the world. Moving to our newer Claris XC290 screen would get you a 3 foot lambert jump. Now, of course, there is a trade-off there, because as you increase the gain, the uniformity of the screen will change, and by that we mean the brightness level from the center of the screen to the edge of the screen becomes more split. So you will see that the edges of the screen become darker. Now, what we wanted to do is to show you some examples of how gain affects uniformity. And in this example, what we wanted to do was to show that jump from a matte white screen to a 1.4 gain screen, yes, it affects the brightness, but we wanted to show you how little potentially it affects the uniformity from a visible perspective. So I'm going to bring up a video. This video is taken from an early release candidate of our forthcoming new releases of app software from the Digital Screen Modeler. And we've built an auditorium here, which we'll jump into. And what you'll see is this is a matte white screen. So you can see the uniformity center to edge around 87% to 100%. That's just under 13 foot lamberts to about 11.2 on the edges of the screen. Now, what you'll see is this is under white projection. So you can't see a hotspot here because matte white screens with one gain are uniform center to edge. Now what you'll see is as we move from the center seat of the R where you would take the light readings over to the far left-hand end of the center row, you'll see the brightness levels don't really drop from the left-hand side to the right-hand side of the screen. And then we'll go ahead and just pop the hotspot back up. And you'll see, if we just jump back in, you'll see here now what we've done here is just taken it from a matte white to a Perlux 1.4 gain screen, and you'll see that the uniformity on the left and right hand side is now about 67%. So we've lost around 15% uniformity, but again, here's that hotspot. Again, you just can't really see that hotspot. So yes, there is an argument you would say that the uniformity center to edge is not within the tolerances of DCI compliance, and we'll show you how you can do that later. But again, you'll see from the left-hand side of the screen to the right-hand side of the screen, there isn't a big drop-off. But what you can see on the right-hand side is just a slight darkening on the very edge of the screen where there's a notable difference. Now, how does that compare and what does that look like visually? Because ultimately, that's the most important thing for you is to know what that looks like. So on screen here are three examples of an auditorium. One is a matte white, one gain screen, a 1.4 and a 2.2. And as you watch this video, I'd urge you to look at the top right-hand corner because that will show you the difference in the uniformity at the most extreme points. And what you'll see is that the uniformity is shown as a sort of a darker image in those corners. So if you look at the Matte Plus screen to the Perlux High White 2.2, you'll see a much grayer sky. And that really illustrates it. But when you compare the Matte Plus 1 gain screen to the 1.4 Perlux High White, there's virtually zero difference in that image quality. So again, that just shows you that that 16% drop-off in uniformity that you'll see from the center to edge, yes, it looks as a figure quite significant, but in terms of what it would actually look like visibly on screen, it wouldn't necessarily look any different, but what you would have is a much brighter picture. So in essence, taking a one-step jump isn't necessarily that significant in terms of uniformity and visible performance. But in terms of increasing the brightness, it could be significant. Now, as we said, hopping up to a new screen with a higher gain, that does afford you some opportunities to manage the operating costs. So we've got two different examples on screen here, and we'll look at the left-hand one first. So this is a 12-meter screen using a Barco DP2K19B projector running at 13-foot Lamberts. So you can see underneath in order to hit that 13-foot Lamberts, we have on a Matte Plus screen, we're running a 3 kilowatt lamp at 90% power. So our warranty hours are 1900. With a Perlux High White 140, so that's a 1.4 gain screen, we're still running the 3 kilowatt lamp, but our power setting is down at 67%. So actually, we're not running the lamp that hot. We're not running the projector as hard as we potentially would have to with a Matte Plus. If we look at the Perlux High White 180 example, here we've been able to drop a lamp size. So we've gone down to a 2 kilowatt lamp. Our power setting is exactly where we want it to be, around 80% at 30% of the hours. But our warranty hours on the lamp have now gone from 1900 to 3000. So that means a lamp is going to last you another 1100 hours more. Now, if we look at the right-hand example, an even bigger screen, a 14-meter screen, which I think is quite rare in terms of its width, but using a Christie CP2230, again running 30% hours and 13-foot Lamberts. And here we can see on the Matte Plus screen, we're running a 6 kilowatt lamp at 80% power in order to actually hit that 13-foot Lamberts. And that lamp has typically a warranty hour of around 600. Just by hopping to a Perlux 140, we're able to drop the lamp down to a 4.5 kilowatt lamp The power setting still stays about the same, but the warranty hour goes up to 1,000. And by doing that, we're able to extend the life of a lamp by 400 hours. And then finally, the Perlux High White, we're able to drop another lamp size down to a 3 kilowatt lamp. Yes, we're probably having to run the lamp a little bit hotter than we want at 90%, around that 30% hours. We probably wouldn't really want to hit that mark until about 40 to 50% of the hours, but the warranty hours becomes 1,500. So potentially, if you were okay with losing a little bit of uniformity on the 180, if you were moving from a Matte Plus to a Perlux High White, you'd be buying one lamp that would last you for 2.5 times the amount of hours as a Matte Plus, and you'd be using a substantial amount less energy. So what we wanted to do is to really show you that return on investment, because yes, we can sit here and tell you the cost of things and the value of things, but actually to show you in hard numbers what you can achieve is quite important, particularly in the world that we're about to enter into. So sure, the cost of upgrading the screen versus replacing and cleaning the projector components. Well, you saw some examples where some exhibitors had spent between $10,000 and $20,000 replacing projector components. And of course, there's the offset again of running a lower gain screen or an old screen that's aged, and the higher operating expenditure on things like consumables and lamp and electricity to enable you to still get brightness. Now, whatever you do, if you're replacing the screen, then the net result has to be to increase that longevity to the projection equipment. If you're holding on to that Series 1 and 2 projection equipment for, let's say, another 2 to 5 years, you need to look after it. Some manufacturers don't have parts available, so ensuring that we're taking best care of it is essential. And of course, having the best presentation quality will help our moviegoers come back, be more satisfied, and of course, value the movie-going experience, which I know personally I've missed a heck of a lot over the past 12 months. So here's a return on investment comparison. So this is looking at that 14-meter Perlux High White screen that we looked at just previously. So you'll see those three different lamp kilowatts from the previous slide, and now we have some pretty much standard lamp pricing in here. And these may well vary for different regions, but you can see some example lamp prices. The same warranty hours you saw a couple of slides back. An operating hours of 70 per week, so that's saying 10 per day. So typically, let's just say from midday till 10 p.m. An electricity cost of 12 cents per kilowatt, which I believe is ballpark correct for Brazil as an industrial energy cost. So if you look, if you're running a Matte Plus screen in that environment, and that setup is familiar to you, your annual cost of running that projector with the lamps is around about $11,200. Now, if you were running a Perlux High White 1.4 gain screen, your annual cost drops to $6,879. So that's a difference of $4,841. And again, if we move to the Perlux High White 1.8 gain screen, you can see that operating cost falls even further. Now, bearing in mind that the ballpark average cost of a 14-meter Perlux High White screen, including the packaging and the shipping and the install, is around about $8,500. You can see that the payback on doing that investment on a Perlux High White 1.4 gain screen is 21 months, and on a 1.8 gain screen, it's just 13 months. And of course, this isn't just the payback on the screen, it's a saving over a period of time. So of course, once you've paid back over 3 years, the Perlux 1.4 gain screen will save you around $6,000, and the 1.8 gain screen around $16,000. Now, hypothetically, that screen, if in a good condition, will last you for hopefully 7 to 10 years, which means that the savings will continue to accrue, which will enable you to store that money aside, build the capital budget to enable you to then make that projection swap out at the convenient and available time to you. Now, as I mentioned at the start, one of the things that we're constantly being asked about is about the replacement of silver screens, where they're no longer being used for 3D, purely for 2D. And I'm going to hand over to Tony for a couple of slides, and then we'll show you some more video footage. So Tony, over to you.
Yeah, again, it's managing the operating costs. As you can see from the tables there, it's quite easy to save quite a lot of money on changing to a 1.8 per lux screen. And not only that, the major benefit of putting a white main screen in where you're using a silver screen is the difference in presentation. As Richard was saying earlier on about uniformities, the difference in presentation showing 2D on a 2D white screen rather than on a 3D high gain silver screen, it's amazing. I mean, it was one of the big problems originally with people not wanting to install 3D silver screens to show 3D films on. Now there's the opportunity. You don't need to run a high gain screen just to save money on your lamps. You can use a high gain silver screen. You can use a high gain white screen and still benefit from the lamp savings. So, Richard? Return on investment. I can't really read that, I'll be perfectly honest. Can you read that properly, Richard?
Yeah, of course I can. So really, yeah, no problem, Tony. So really here what we were trying to illustrate was that the OPEX saving here is not significant in the way that you saw it from moving from a Mac Plus to a Perlux screen. But the biggest improvement, as Tony highlighted on the previous slide, is about that improvement in uniformity. That's the significant jump there. Now, obviously, you can see that in the left-hand example, we noted the 3 kilowatt lamp. That's on the assumption that you were still running that lamp because that's what you'd had in there from running a 3D system where you needed the brightest lamp in order to get some brightness.
Yep.
So what we now wanted to do was to show you a uniformity comparison to try and help you understand the visual impact that running a silver screen would have normally in a 3D setting, but actually then if we carried into a 2D setting, what that would look like. So again, back into our digital screen modeler, what we're going to do is show you, this is the screen that we've just talked about. So roughly 4.5 foot lamp that's in the middle. This is running as a 3D screen with that 3D system in. So you can see that center to edge uniformity is pretty stark, the difference. So you'll see in a second precisely what will happen when we switch to the hotspot. So you can see a big shining hotspot in the middle, and that's where the light is being reflected back directly down the auditorium. Now this hotspot moves along the screen with you as you move along the aisle. So of course, if you're sat on the far left, you're talking about the best part of a 90% drop off from the left-hand side to the right-hand side. So it's going to look pretty bad. But of course, you know, what happens in 2D? Well, of course, if we go to 2D, now the center screen brightness is 27 foot Lamberts, sure, because we've taken the 3D system and the glasses out of the way. What we haven't done is change the hotspot. It's still the same hotspot. Even if we drop lamp sizes down, that hotspot is still the same. The uniformity center to edge is still the same. Nothing changes. So that means that we're stuck with a poor presentation. Now, if we come in and we change to a 2 kilowatt lamp to bring the brightness down to roughly within the specification, we still haven't changed the hotspot. We've just brought the brightness level down. There's that hotspot, still very big, very bold, very visible in the middle of the screen. So what happens if we then make this significant change, which is to change the screen itself to a Perlux Highlight 1.8 gain screen, as we showed in the example previously? Now, what you'll see as we jump back into the auditorium is, yes, our brightness level has come down because, of course, we've jumped from a 2.4 gain screen to a 1.8, but the center to edge uniformity has now improved. And of course, our hotspot is now much bigger than it was. So a more uniform picture from the center to the edge of the screen. Still not perfect, but a significant improvement. Here's this video again, and this time you can see the spectral screen versus the Perlux White 1.8 gain screen, and you can see the darkness very visible around the outside of the screen the whole way around this time on the spectral screen versus the Perlux 1.8 gain. Now, of course, one of the other metrics for us to look at from a return on investment perspective, particularly in this case where the difference really in OPEX is only around $800 in savings of lamps, is what's the implication from being able to sell more seats. So if we looked at the auditorium, if you recall back to when we moved to the end of the row with the spectral screen and you saw that uniformity drop off, really you're starting as you get to the more oblique angles, so the more difficult and challenging angles, so typically the very front corners of the seats. Those seats have very poor presentation in comparison with obviously the middle of the auditorium where the light is directed to. Now on the screen now are two seating maps, and the idea of these seating maps is to illustrate the quality of the viewing experience from each of those seats. Now with the spectral 240 screen, you'll see there's some orange and red seats visible towards the front, almost in a sort of a cone shape. And those will be ones that particularly you would try not to sell in any given environment, because you're going to have customers that are disappointed with the performance that they get from those seats. Swapping over to a Perlux High White 1.8 gain screen means that hotspot is wider, the viewing experience is better for every seat, and now you're potentially able to sell those seats. I'm just looking on screen, that's probably around about 40 seats in the auditorium. So being able to sell, let's say, 20 to 30 more seats every single performance, even at 50% capacity, means 20 more tickets, 20 more sales of concessions. So potentially just by swapping the screen out, you're able to open up more seats, particularly right now with social distancing. You'll be able to seat more people inside of the auditorium and leave them satisfied and generate some much needed incremental revenue. Now, of course, one of the things that we spoke of a little earlier, and I alluded to the fact that we would talk around this, if you were moving from, say, a Matte Plus screen to a Perlux 1.8 gain screen, is potentially the consideration for optimizing a screen if you were installing a new one at the time. Now, this would mean work to the screen frame itself, but you can make some significant improvements to presentation quality just by optimizing the screen itself. Now, with gain screens, as we've seen from the examples previously shown in those videos, there is an importance to make sure that we're doing the best with those screens to open that light back up as best as we can, so that the presentation quality is as good as it can be. Now here in the modeler, what we're going to do is run an example where we're going to show you the effects of curving and tilting a screen. So we're going to start off on the silver screen. This is the Spectral 240 that we've been using as an example throughout the last segment. And what we're going to do here is just show the effect of that hotspot on screen. So hopefully, there we go. So you'll see as we jump into the auditorium, there's that hotspot back on the screen, again, moving around with us. So you can see here, this is a slightly bigger 14-meter screen we looked at, but the center to edge uniformity is around about an 83% drop off. So that hotspot is very pronounced. If we come in and we just curve the screen by around 2%, you can see that we move up. We've still lost a significant amount of light, but we've gone from around 17% to 26.5%. Now, what effect is that going to have in terms of the hotspot? Well, you can see the hotspot, rather than being sort of circular, is starting to stretch itself out and become a bit more of an ellipse. If we go for a deeper curve, around 5% curve, you can see that hotspot is widening again. So it's going from sort of a circle to out here. And now you can see the uniformity has come from 17% to around about 50%. So it's a significant uplift. And at 5%, the curve doesn't affect the image particularly from an alignment perspective, and certainly not from any other perspective that your moviegoer would see. So you can see by that stroke, we've made the hotspot wider. Now, what we didn't have was a hotspot in the middle of the screen. It was towards the bottom. So here, what we're doing is going to place a tilt on the screen. And what we're going to do is tilt the screen forward. So we're pushing the light from the projection path where it's been hitting the screen and almost because of the path of the light going down, what we're actually going to do is to tilt the screen forward, and it brings the light back in towards the center. Now, doing that, you'll see that we've started to adjust the uniformity between the top and the bottom slightly. Now, we're going to put a much more exaggerated tilt than we would normally suggest, with 2.4 degrees, and bring that screen forward. And what you'll see is the top and the bottom will now have that almost identical uniformity of around 50% and 45%. Now, obviously, that's quite significantly exaggerated. Typically, you wouldn't tilt the screen by more than 1 to 1.5 degrees, but we just wanted to illustrate that. And again, you can now see that the hotspot, rather than being at the bottom of the screen circular, is now elliptical and in the middle of the screen. So that means that your presentation quality is going to be significantly better on a high gain screen. Now, of course, if you're going for a lower gain screen itself, like a 1.8 gain per lux, it's not essential that you curve the screen. Certainly anything under that probably doesn't need curving at all, but you can absolutely talk to our technical teams, both in the Americas and in Europe, and we can give you that guidance to tell you whether you need to curve a screen or whether just a flat frame is still going to be okay. So now what we wanted to do was talk about some of the issues for those of you that have already upgraded or have already commissioned laser projectors to come into your fleets, and the implications from a screen perspective upon those. Now, one of the most challenging discussions within the industry over the past 18 months to 2 years has been regarding laser speckle, and particularly the impact of the screen in creating speckle. Now, for those of you that don't know, there's a description on screen, but speckle is an interference pattern. So it affects all laser projectors, but to a different degree. You'll see it more visibly on RGB projectors. That's just natively to do with the bandings of the light. And it can potentially cause a disruptive viewing performance and experience for moviegoers. It's one of those things where once you spot it, you can't unsee it. But if you haven't seen it, you may not see it. Now, there are ways of mitigating it. So some projector manufacturers deploy screen shakers behind the screen to slowly vibrate the screen, which enables the speckle to be mitigated. And some other projector manufacturers will do things inside of the engine itself of the projector to try and mitigate speckle. But speckle is also influenced by the type of screen surface that you have. Now, when you look at what the visual factors are likely to be, well, it's the distance from the screen surface is a perception factor. So the closer you are to the screen, the more visible speckle tends to be. So if you're in a long shoebox auditorium and you're stood at the back, you'll see it much less significantly than if you were stood in the front few rows. However, if it's a short and wide auditorium, it's likely to be more evenly pronounced across the entirety. Brightness levels, of course, are a perception factor, because the brighter the image is, the more pronounced the speckle will be. And of course, our own eyes. Everybody sees the world differently. Everybody's eyes are different. And therefore, we will all view speckle in different ways. Tony and I have looked at screens where Tony can see speckle and I can't. And he can't understand why I can see it, why he can see it and I can't, and vice versa. It's just the way our eyes operate. And we've done a lot of research into this over the past 18 months to 2 years. We've worked with Christian Barco to produce 2 pieces of research on laser speckle and the visibility of it using our screen surfaces with their projectors. Those 2 documents form quite chunky reports. They're both available via the Harkness website, both obviously endorsed by the relative projector companies themselves. But the key findings for those really is that if you're swapping out a lamp-based projector to a laser projector, particularly an RGB because of the bandwidth of the light sources themselves, without considering the screen, you could introduce the visibility of speckle. It's not to say that speckle isn't there if you change the screen, but it becomes more noticeable. So, for example, if you deployed an RGB projector with a spectral 240, the high gain, the technology itself in the screen is likely to make speckle more pronounced. Now, speckle is significantly less visible with laser phosphor. It is still there. It can potentially be seen, but it is significantly less visible. Our recommendation is always to only use a silver screen where you're using polarized 3D. Try not to use a silver screen for 2D. So if as we've discussed previously, if you've taken a 3D system out and you're only showing 2D, definitely change the screen if you're going to change the projector to a laser projector. And potentially try and get the lowest gain screen you possibly can, because lowering the gain of the screen helps you to mitigate that visible speckle. And of course, if you've gone through that process of commissioning up an RGB projector, one thing we can tell you is it's significantly cheaper to change the screen to a lower gain screen than installing screen shakers onto the existing screen you've got, with all the perils of damage and fragility of a screen that may have been in there for 7 to 10 years. And then lastly, we wanted to tell you about some of the work that we've been doing behind the scenes over the past 14 to 15 months to hopefully help support you as we come out of this crisis. We're currently working on a project called Compact Plus, and we're trying to finalize the brand new foldable 3D screen technology. Now, this is very different from any other foldable 3D stroke silver screen that's on the market from other sources. What we've tended to find previously is that other screens that claim to be foldable are still existing technology, just with a different folding technology deployed. This is a completely new technology built from the ground up, which, yes, can be folded, but still has some significant quality improvements, enabling you to still have a premium 3D screen, but foldable without any damage visible on the screen itself. And of course, once that rolls on into our product portfolio, that will be complementing our absolute best-in-class foldable Perlux high white screens, which are the choice of exhibitors that are looking for foldable screens. Now, the big advantage here with foldable screens, of course, is that if you're looking to put a new screen into an existing auditorium, sometimes trying to get those long tubes, or even the screens once they're out of the tubes on a flexible inner, trying to get those through some of the cinemas is very difficult. It can sometimes mean punching holes through walls, cutting holes in ceilings to lower screens in. Actually, having a folded screen inside of a box can make it much easier to install, can bring the install costs down quite significantly. So keep an eye out for our Compact Plus range. Hopefully we'll have some very significant news on that in the coming months. Now, throughout this presentation, we've been showing you some video footage captured from the alpha releases of one of our apps, a digital screen modeler, which is going to form part of our new by Harkness technology package. We believe this is going to completely revolutionize the way that you specify and design screens and also interact and communicate with us. We are still working on this. It's a significant technology project for us as a business. We are hoping to be able to launch that towards the last quarter of this year. But you've seen the significant uplift for those of you that have already been using our apps inside of the modeler functionality, just from what you've seen in this very brief alpha shots today. We know that you're going to love the new features in them. The collaborative platform we're building behind them will enable you to work not just with us, but with your teams and your partners and your integrators to try and ensure that you're always getting the best outcome from your investments. And of course, our very skilled, very passionate, and incredibly creative research and development team here in the UK have been looking at the next generation of screens that will follow beyond those that you can buy today, and including the Compact Plus screens that are coming, looking at how we can further help to reduce visible speckle on screen. So we are very busy, we're ready to go. We want to help the industry get back going again, and we believe that some of the technology we're working on is going to help revolutionize that. So I'm going to hand back to Tony for a wrap up before we turn over to questions. So Tony, over to you.
Thanks, Richard. Yeah, hope you all enjoyed that presentation, particularly with the new app. I'm looking forward to using that with customers. Right, key takeaways. We know the industry is going to take some time to reboot, particularly while we're waiting for Hollywood to come out with its blockbusters, so exhibitors can start to put a little bit of a war chest together and start to invest again in their cinemas. But to do that, we've got to wow the audiences. Presentation is king. We don't want them sitting at home looking at that little square box in the corner. We want them queuing up to buy popcorn, gummy bears, Coca-Cola, Pepsi-Cola, and get in and watch the film. Putting a plan in place for short, mid, long term to keep your presentation quality as good as it can be. It can be difficult. You've got the staff to do it. It's investment in training, which is not that much, but it can be done. And small investments can improve your moviegoer experience. We all know that. So it's keeping an eye on that presentation. To us at Harkness, the screen is the most vital part of the auditorium. Sadly, our product can't be seen. You can only see the picture on it. So that's what makes it so good. It's got to be a good screen. And in cinema, there's no argument. The picture came first. It wasn't sound, it was the picture. The picture came some 40 or 50 years later. So the screen is very, very major part of the auditorium. If you keep in touch with us, once we've got the app up and running and out there, we can help you. We can help you make these OPEX savings and learn where the ROI is. So, yeah, Richard.
Thanks, Tony. So that's the end of our presentation. Hopefully Marcello is going to rejoin us on stage for the Q&A session.
Sorry, I was on mute. Thank you very much, guys, for the presentation. It was really didactic. I have some questions about business. I know we talked a little 2 weeks ago, talking about on other markets, just to show to the Brazilians to be more optimistic. So we know that you are making business with India and China, and we know there the box office is almost the same number as we compare with the pre-pandemic period. So how are the business there for Harkness?
China was shut for a period of time. They reopened once and then they shut down again. I think the major reopening is where they've reopened in time for the Chinese New Year. Believe it or not, this Chinese New Year, the box office has been bigger than any other Chinese New Year by almost threefold. So it's, I think it's a combination of everything. I think it's a combination of people wanting to get out. The cinemas are all in shopping malls. So it's getting out, it's meeting your friend, it's doing some shopping, and it's spending money and getting the opportunity to go to the cinema. So it's all wrapped up in one big thing. And we've got to remember that it's a big, big holiday for the Chinese.
And the beauty they have there, Marcello, is that they have local content, and they've had
and they've got a very good local content film at the moment as well. India was similar. India was shut for quite a while. And when they reopened, it was a lot of the bigger multiplexes in shopping malls opened first. Some of the smaller provincial screens didn't. And again, they've got their own content. They've got Bollywood content. And it's still very, very big in their cinemas. So with your own content, you know, you can make the addition. You don't need to rely on Hollywood.
Good.
France was similar, although they're still shut at the moment.
And are they looking for new screens?
Yeah, we've one of the problems we had in India is we were doing a lot of refurbished work where they were changing seats and things like that, and we've still got screens in stock that they ordered prior to the pandemic. Well, we've got the orders there. They're not in stock. We've got the orders. So we're waiting for them to get into a position where they can start to install the new screens.
Good.
So China's still building a lot. The building in India's slowed down a little bit, but China's still building a lot. Denmark never closed. And they've got local content, and they were doing really, really well.
Good.
Sweden. So there are countries that managed to go all the way through it and were showing. But as I said, local content. And good. I think that the screens that have probably done the best in England when we were open for that period were the independents, because of their local audience. They know their audience very well, so they were showing a lot of alternative content, things like that. They know what their audience wants to see, and a lot of their audience is not blockbuster dependent. So
that's great. We have a question from Jay Spelling Right from Tecnologia Junkie. He's asking about the supply chain issues due to the pandemic. Are all its factories up and running?
Yes.
What about the issues with shipping to customers and installing?
It's the only France is up and running, which does all of Europe, Middle East, Russia, etc. But we're running it at reduced capacity. India is similar. It's up and running again at reduced capacity because we're waiting for these orders to be placed again. China's running at almost full capacity, making screens for IMAX and a couple of new customers we've got. America's doing very little. They're running at reduced capacity. I think America's been the biggest problem because the world, or the cinema world, is so reliant on the American blockbusters and the American cinema industry. A lot of it being because of all the integration, where you've only got 3 major exhibitors, and those 3 major exhibitors have all shut so many cinemas all across America. When are they going to come out of it? And of course, if you're trying to look after 10,000 sites, it's a lot harder than trying to look after 5,000 sites. 10,000 sites in 4 countries is very, very difficult. Shipping to customers, the only shipping problems we had was in India, because you weren't allowed to travel about. But most of the other places we managed to ship. Installing, it was just a matter of waiting until cinemas were open to do any work in. One of the problems we had in England was the site was open to do work in, but you couldn't get any workers in there because there was nowhere to stay, because all the local hotels were shut. So you had a chicken and egg situation. The workers didn't have anywhere to stay. So until the hotels opened, they couldn't finish the project off. But most of the outstanding projects in Europe, I think, are done. I think they're almost done. Now we're waiting for new projects.
Good. Thank you, guys. Was very good. I really appreciate your time and
Okay.
Alguém mais gostaria de fazer alguma pergunta? Eu acho que não, né? 3, 2, 1. Então, bacana, gente. Obrigado, Richard, mais uma vez. Obrigado, Tony. Estamos finalizando aí o segundo dia da Exibidor Tech Week. O link para acesso desta apresentação e de todas as anteriores, de hoje, de ontem, estão todas na caixa aqui de descrição do vídeo. Vocês podem baixar e ter acesso. Lógico que as transmissões simultâneas só funcionam ao vivo, então, infelizmente, a gente não vai conseguir disponibilizar isso. E, lógico, para que vocês não percam mais nenhuma apresentação, se inscrevam no canal. Quem já está inscrito, clica no sininho. Isso é importante para vocês receberem alertas para novos vídeos que a gente venha a ter. Amanhã, às 16h30, a gente vai ter um panorama da tecnologia em contexto pandêmico com o Jorge Dantas, da Sharpneck. E às 5h30 da tarde, todos voltam ao vivo junto comigo. A gente vai fazer um bom bate-papo, né, discutindo o presente e futuro para os prestadores de serviços e na exibição cinematográfica. É isso, gente. Obrigado mais uma vez. Até amanhã e vamos que vamos. Até mais.